Before I get into the details of using the Java Collections Framework, I wanted to take a look with you at the online documentation and specifically at the java.util package, which is where the vast majority of the Java Collections Framework capabilities are defined. There are classes in other packages that are based on the Java Collections Framework as well. So I'm going to go into the online doc set here and scroll down to the java.util package. And when I click that, not only does it show me in the lower left corner here all of the features of that package, but it also gives me a link to an overview of the package itself, which I'm going to click here. And you'll see that it starts with the set of interfaces that are in this package, as well as the set of classes, and then down below there's one enumeration and some exceptions classes as well. So the main reason I wanted to look at this is to show you that there are a wide range of data structures capabilities built into the Java class libraries. And within this interface summary, you can see that there's quite a number of interfaces, and if you're familiar with data structures in general, you'll recognize a number of the type names that are used for the interfaces here. Now, one of the key interface types is the collection interface, which is the super interface or the root interface for the entire collections hierarchy. If you take a look at that interface type, and I'll click the link now, and then go to its method summary, you'll see what are mostly the common capabilities of the various data structures that we'll be manipulating. Things like being able to add an item to a collection, or add all items of another collection to a collection, to clear out the contents of a collection, or determine whether or not a particular object is in a collection, etc. So we've got quite a number of capabilities that are common to the different collections classes, and the nice thing about the fact that most of those classes implement this interface or one of its sub-interfaces is that you become familiar with some of this functionality, and then you know how to use it across all of the different classes in the collections framework. So let me go back to the interface summary. In addition to the interface collection, there are several other interfaces that we'll be focusing on here today. One of which is the set interface down at the bottom here. A set is a collection of elements that contains no duplicate items, and the set interface lists out additional methods beyond what we have in the collection interface that are specific to sets of data. Also, we have the list interface, and the list interface represents things we can perform on a linear linked list style data structure, or as we'll see also an array list, which is an implementation of the list interface that uses an array underneath the hood. In addition, we have a map interface, which is for hash table like data structures, any data structure in which you would like to store key value pairs, where the key is used to both store and retrieve the corresponding value. And then also you'll see things like the queue interface for implementing data structures that are first in, first out style data structures. And there's a lot of other interfaces here as well. For example, you'll see that there's something called a sorted map and something called a sorted set. Those are more specific types of maps and sets, respectively. Now, one of the things you'll notice with a lot of these interfaces is the set of angle brackets following the type name, and usually you'll see the letters E, T, K, or V inside of those angle brackets. The collections framework in Java, when it was originally developed, was developed specifically to store objects of any type, which meant that in any given collection you could have any type of object you wanted. In most cases, when you're processing a collection of items in a program, they are usually of the exact same type, or they're usually related by a class hierarchy. For example, I might want to process some sort of a collection of employees or a collection of shapes. Well, as of Java Standard Edition 5, they added to the Java language a concept called generics. For those of you who might be coming from the C++ programming language. It's a similar concept to the concept called templates in C++, or similar to the concept called generics in some other languages as well. So we can now in Java, rather than just storing the generic, well, that's a bad word, the concept of an object, rather than just storing objects, we can now store specific types of objects. So I can say I want to have a list of employees, or I want to have a set of strings, and I can, because of that type specifics, I get additional type checking at compile time that helps me write more robust applications and helps me guarantee that the collection only has a specific type of object in it. And this also helps me not have to worry about downcasting operations. With the old style collections, when I wanted to process an object that was stored in the collection, I would get that object out, but it would be given to me as a reference of type object. And in order to use that reference to do something useful with the actual type of the object that the reference points to, we would have to first downcast that variable to the specific type of object that we were manipulating, and only then could we manipulate the object using its specific methods defined in its class. Well, the problem with that is what happens if, in fact, the reference is referring to the wrong type of object, and then I cast the object to a type that it is not. In that case, we would get a class cast exception. So another benefit of the concept of generics is that once I say I'm only going to store, say, employees inside of a collection, I know that all of the objects in that collection are employees, and therefore when I get them back out of the collection, they are given to me as type employee, and I no longer have to worry about possible problems with class cast exceptions. So we'll take a look in the lesson at various examples that are using these generics capabilities. When you see the letter E in a generic, it usually represents the fact that we're talking about the type of an element within the collection. When you see the letter T, it's just a generic name for the concept of a type of a particular value that you'll be processing. And when you see the letters K and V, they specifically refer to the key type and the value type respectively in a map or hash table like data structure. Now, in addition to all of these interfaces, there are many classes in the java.util package. Not all of them are part of the Java collections framework. Some of them are just general utility classes that have been in the java.util package since Java 1.0. But you will notice at the very beginning of the class summary a bunch of classes that start with the word abstract. These are all partial implementations of various collections interfaces that we looked at up above, and these are specifically geared to you being able to extend these classes and provide your own functionality for implementing your own styles of data structures that will then mesh well with the Java collections framework. On the other hand, there's also many concrete classes that we'll be looking at. For example, we're going to be taking a look at the ArrayList class shortly, which is a list implementation that is created or implemented underneath the hood as an array and then manipulated as a list style of data structure. We'll also be taking a look at several other classes. For example, the concept of a hash map is a hash table-like data structure that maps keys to values. We'll also look at hash set, which is a set of values that are all unique. We'll look at linked list, which is a linked list data structure. In fact, it's a doubly linked list data structure, which means we can walk both forwards and backwards through the list. And we'll also take a look at a couple of other classes. For example, we'll look at tree set, which is a sorted set implementation, and a tree set maintains all of its items in sorted order at all times. And there's many other classes in here as well. One of the things that you should at least be aware of is the fact that Java originally did come with certain data structures. For example, the vector class is one of the original data structures that was built into Java from version 1.0. Now, back in Java 1.0, the data structures that they implemented were set up as synchronized data structures, which meant they could actually be used by multiple threads of execution in parallel because all of the operations on these data structures were synchronized, and that would prevent more than one data structure, or I'm sorry, more than one thread from modifying the data structure at a given time. With the collections framework, the data structures are not synchronized by default, and they do that for performance reasons because there's a lot of overhead associated with synchronization. But towards the end of this lesson, we'll talk about the fact that there is a way to get what I would call a synchronized view of any one of the collections framework classes that would enable you to use that collection class with a multi-threaded application properly. Separately, there are now concurrency APIs that enable you to do true multi-threaded application development and that provide other data structures that are geared specifically to multi-threaded applications and can even let many different threads interact with a data structure at the exact same time, but yet still maintain the data structure in a way such that it can't be corrupted by those multiple threads of execution. So we've got quite a number of things to look at in the Java Collections framework, and what we hope to do here is give you enough information that you can build on your knowledge to learn the other data structures on your own.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.